Welcome to another PLC Professor presentation. This one is going to cover I/O and channel configuration, and we're going to compare the Micrologix1000 and 1100. The reason that we're comparing these two processors is that the Complete PLC Learn series was designed to use the pro gratis version of RSLogix500 called MicroStarter Lite. MicroStarter Lite can be downloaded from Rockwell. It supports only two processors, the Micrologix1000 and the Micrologix1100. The 1000, you can purchase one from an AB distributor for around $150. The 1100, however, is much more expensive. This presentation is being recorded to replace an earlier recording that is part of the Basics lab lecture wrap-up discussions. We will probably discuss more than just I/O configuration and channel configuration because, as is my wont, I like to reiterate certain features of the software as I'm going through very specific explanations. They say that if you hear it 10 times, you'll remember it. I always aim my lectures at the novice or the beginner. If you are more advanced, then this presentation will probably not work out well for you. Let's begin by opening an instance of RSLogix500. Now, this might be MicroStarter Lite for you. I just happen to be using RSLogix500 Pro. All the instances are basically identical until you create a project. Let's create a new project. We go to File, New. Now, this is the first thing that you're going to notice if you have MicroStarter Lite. When you get to this point, you're not going to see all these processors. The Pro version supports all of the processors that use RSLogix500 to write programs for. We could give it a name. The processor name and the project, the offline project name, is really not the same. They start out the same, but later on, if you change the name of the project, remember you're offline. You downloaded something to the processor with a name. The processor still has the same name because when you're offline and you're changing the name of your projects, that does not change the processor name. So we'll just type in, we're going to make this a 1000, so we'll just type in ML1000, Micrologix1000. We're going to pick a Micrologix1000. But before we do that, let's look down through this list. You can see the first handful here are all Bulletin 1747 processors. These are all SLC 500 or 505s, as we say. Till you get down here, then you see 504. The 505, the SLC 505, those all had two COM ports, RS-232 and Ethernet. The 504, scroll down here, these all had an RS2 or have an RS-232 port as well as a Data Highway Plus port. And then the 503, which was more common, the 503 had two COM ports, RS-232 and DH-485. And then you also see 502 and 501. Those are all grandpas. I have not seen one of those in years. Very limited capabilities. If you have one that works, that's fine. As a matter of fact, for doing real simple things, there's nothing wrong with a 501 or 502. I don't think you can even buy them anymore. I'm not even sure you can buy the 503 anymore. You can always find stuff on eBay, and you can go to these PLC repair centers, and they usually have some of these older processors available. So now you see we're into 1764, 1766, 1762, 63, 61. These are the Micrologix processors here. Starting at the bottom, Micrologix1000, 1761, three of them. And then the 1100, 1763, 1762 is 1200, 1766 is the 1400. And then 1764 is the 1500. These originated first, the 1000 was the first Micrologix, then the 1200, then the 1500. Then came the 1100, and then the 1400. The 1400 is really the piece de resistance for Micrologix. It has the greatest capability, has built-in Ethernet, it has the best of everything. I would say the 1100 comes right behind it because the 1100 has built-in Ethernet and it has a good instruction set and it has online programming. Where some of these other Micrologix, like the 1000, which we're going to pick now, does not support online programming. That means that you write the program, offload, download, go online, monitor. But if you want to make a change, you have to save, go offline. You don't really have to save unless you want to save your data table values. But you have to go back offline, make your changes, and re-download. The only two here that support online programming are the 1100 and the 1400. Today we're going to pick first the 1000, then in a few minutes we'll pick an 1100. So I'm going to click on Micrologix, say OK, and voila, there it is. There's your Micrologix 1000 project. We're going to open I/O configuration first. Now notice there's no plus sign in front of either one of these. Like they're here, if I hit the minus sign, now I got a plus sign, right? Plus sign just means there is more. Now we don't have help expanded because we don't want to eat up our vertical space that we have in our screenshot here. So let's go to I/O configuration first. Double click and we get a pop-up. If you look, you see there's really nothing to do there. The only thing that is really active is the filter adjust, and this allows basically a debounce timer, and you can do it for inputs 0 and 1 and 2 and 3 in separate groups. Then your third group would be input 4 to whatever extent that you have. And you see you can adjust these filters to 8. It comes default 8 milliseconds, but you've also got 4 milliseconds, 2 milliseconds, 1 millisecond. Now you're down into fractions of a millisecond, which we would probably say, in this case, 100 microseconds, 250 microseconds, 500 microseconds, or 1 millisecond. So we'll leave it the default. I've never changed these. I've never needed a debounce timer. This just basically filters out noise out of the input signal coming in. So if you have a noisy field wiring for an input and you're getting little spikes here of less than 8 milliseconds, this 8 millisecond filter will basically, it tells the processor to ignore any state changes that don't last longer than, just ignore anything less than 8 milliseconds. If it's 8 milliseconds or more, then that's an actual input state change. Okay, so there's nothing to do here simply because Micrologix 1000 has fixed I/O. You cannot expand the I/O for the Micrologix 1000. Let's close that and open up the channel configuration. Well, this Micrologix 1000, you really don't have much to choose from there, do you? So you can pick a different baud rate, and I guess I'll explain. There's two ways you can do this. First of all, when you actually start working with this processor, you want 19,200. You can see these are multiples of 2, basically 300, 600, 1200, 24. Then times 4. We're not going to explain baud rate right now. Basically means the communications rate. Because this is serial communications, both ends have to agree on a baud rate. Otherwise there's going to be confusion because they're expecting the serial data to change state at a certain rhythm. And if one end was 9600 and the other was 19,200, the 9600 end would be sending data at a pulse rate where the individual serial pulses represent ASCII characters, and the other end, set at 19.2, would be reading those bits at twice the rate. Yeah, 19.2 is twice 9600. So it would read each character twice And so if you said hello Bob, you would get HHEELLLLOO space BBOOBB, because the 19.2 baud rate, it is assuming that you're sending at the same baud rate. That's enough for that. So there's not much to pick from here. It comes at 9600. You should pick 19.2, but you don't have to do it right here. The reason, well, we'll explain that in a minute. We'll just leave it 9600 because it's okay to start there. Okay, so there's your Micrologix1000 project. We went through I/O configuration, channel configuration. You're probably thinking, I didn't see any I/O configuration or channel configuration. Well, you didn't, because there just isn't much to configure with the Micrologix1000. However, when we get to the 1100, you will see a different story. Let's do one more thing before we add another instance of this software with a Micrologix1100. Let's change the controller. So go to Controller Properties. Now we could change it to an 1100 right here. We really haven't written any code yet. We haven't configured anything, so it really wouldn't matter. But let's pick another 1000. Apply. You're always going to get this message when you change processor type, because different processors have different data table structures, and they also could possibly have different I/O. So if you know that you're going to go to a processor that has different I/O, then you might want to clear the I/O when you do this. In this case, we're just making a simple change. So we just click OK. OK. Now let's open up. We open up I/O configuration. It still looks the same. But when we open up channel configuration, notice now that we have two different selections, two different protocols, DH45 and DF1. DH45 is addressable. You can have 32 nodes on Data Highway 485. DF1, or just straight RS-232 DF1, is not addressable. It's just a point, so it's point to point. DF1 is selected right now, and the baud rate is 9600. But notice now that you can have a node address. That's because we picked a slightly different model of Micrologix1000. However, you want to leave it at DF1 because DF1 supports auto configuration, and you know from your RS Links tutorial that if you have auto configuration, then you just click on auto configure, and the software, RSLogix 500 or MicroStarter Lite, by way of RS Links, sends a message out on that driver, out the COM port. It sends it out at a specific baud rate, parity, stop bits, etc. It sends out a message at a particular configuration. If it doesn't hear anything back, then it changes one setting and sends it out again, and it keeps changing settings one at a time until it hears back from a processor out there. Now, if it never hears back from any processors, it gets all the way, it's gone through all the different iterations, and it does not hear back from any processors, then it gives you another message that basically says you don't have a cable, something's not powered up, something's just flat wrong. However, if you do have a cable, it's the correct cable, and your processor's powered up, eventually it will get back a message, and then it will set the driver configuration settings to match the processor, and that at that point you're golden. So if you go to download and go online, you can do that. Now keep in mind the processor comes 9600 from the factory, so your auto configuration is going to yield 9600. But notice this is the only real difference between the Micrologix1000 and then the other Micrologix Slave Master that we picked. So we'll say OK. We're not going to change anything. I just wanted to show you that. So we will then go change this one back. See, DH45 HD Slave. Now there is one other one. I'll go ahead and pick that one, the analog. Again, it's warning you. Okay. Now I/O configuration. still looks the same. Channel configuration still looks the same. However, if we go to our data files, we might see something slightly different in here, because now it's going to allow for analog inputs. But we're not going to dwell on this for right now. So I'm going to go back one more time, controller properties, and I'm going to change it back to just a straight Micrologix1000. Apply. Okay, okay. And now we're back to where we started. Now we're not going to create any code. We're not going to write any programs. We are just covering I/O configuration and channel configuration. Now let's open another instance of MicroStarter Lite, or in my case Micrologix1100 Pro. And you notice I put it right next to the one that we have open. And you can't see everything that I see, but I have extended these two instances below and outside of your view of the screen capture area. The reason I do that is because I need to be able to click on them to switch focus of windows back and forth between the two. But what you see on the screen is fine. So we just opened up this instance of Micrologix 5. And by the way, you can open up as many as you want, whatever your computer's memory and operating system can handle. So we go to File, New. Now we want a 1100. So we go down to the Micrologix series, and we'll just pick a series B 1100, and voila, there it is. Now at this point we want to compare these two instances of MicroStarter Lite or Micrologix1100 Pro, because you could be doing this as well on your screen. In other words, you can open up two instances, one with 1000, one with 1100, and do exactly the same thing I'm doing. Now, one thing that I want to reiterate here, when we were talking about baud rate, when you are working in the realm of Micrologix1100, really when you're working in the realm of any development software with a PLC, the baud rate resides in three locations. The first location is the first place that you would probably see it. Well, it depends on what order you do things in. If you write your program offline and you're not concerned about RS links, then in your offline project, which you're looking at right now, you would go into channel configuration and set the baud rate, or look at the baud rate. We'll do that. Well, you looked at it already. You would look at the baud rate here. That's an offline setting. Then when you go to download, you need RS links. RS links has drivers for you to communicate between this software, MicroStarter Lite, Micrologix1100 Pro, and the processor. That driver also has a baud rate setting. The driver itself has a baud rate setting. So that's two. You've got one in the offline project, you've got one in the driver. The third location is in the processor itself. When there's no cable connected between your computer and that processor, in your realm that you're going to work, you've got two settings, one in the processor, one in your offline project. And then when you go to download, there's a third one in your RS Links driver. They all three have to match at some point. But always keep in mind when you're going to do something, who's on first, who's on second, who's on third, and if you pay attention to that, you'll hit home runs every time. And RS Links is really the key, because when you open up RS Links and you do a who, or you look to see who's out there, if you don't see the processor, you're not going to communicate with it. So until you see the processor that you're interested in showing up as under the influence of the driver you created, until you see that, you're not going anywhere. Okay, we bring both of these projects into the screen view for you, and we try to line them up exactly parallel and level with each other so you can compare the two. And right away, I know you see some differences if you're just even casually looking. The function files are the first thing that you see under And we didn't give this one a name. So you know what? Just for grins, I'll go into controller properties, and I open up controller properties by double clicking on it. Processor name ML1100. Okay, they really didn't change anything other than the processor name. What's interesting is it doesn't show up here right away. I don't know if we do a refresh if we would see it or not. Well, I don't want to get too far off the subject here, so I'll leave that alone. This is our 1000, this is our 1100. We'll save it. And so, okay, we'll save it, and we'll give it the same name. Now remember, I'm saving the offline project, not the processor name. I'm just trying to get, there it is. So now it says 1100 and 1000. I really wanted that up there because I didn't want any confusion. We'll do the same thing over here. We'll save it, and see it says Micrologix1000. Okay, now we'll click back over on this one. So now they look the same, ML1000, ML1100. I want you to make sure you keep track which is which when you're looking here. Now, the easiest way to know which is which is if you look at the project view of the 1000 over here. This part looks pretty much the same, other than channel configuration has a plus sign next to it, and you see function files here. Okay, you don't see that over here. Function files. Function files are a collection of status and control registers. These exist only in the Micrologix 1100, 1200, 1400, and 1500. You won't find these in the 1000. And contain the control file information for a number of instructions. The high-speed counter instruction, the pulse train output, the pulse width modulation, the selectable timed interrupt, and the event input interrupt. Those 5 instructions, the HSC, PTO, PWM, STI, and EII. Does it matter right now whether you know those or not? Not at all. As a matter of fact, the only 2 of those that you're going to see in the whole Complete PLC Learn series, which was designed around the 1000, not the 1100. Remember, the 1000 does not have these. But in the 1100, we are going to do high-speed counter and selectable timed interrupt in the 1000 with the manual. You should be using the manual with these videos. The function files also provide hardware setting information, or the hardware setting information for the controller, for the real time clock, the RTC, the liquid crystal display. 1100s and 1400s have a liquid crystal display right on the front of them that you can actually write little programs for, develop little screens for monitoring. It also, for the 1500, the function files would do data access terminal, or DAT type information. There's also trim pot information, memory module information, base hardware information, communication status file channel 0, communication status file channel 1, communication status file channel 2. That's the 1400 only. And then Ethernet communication status file for the 1100, Ethernet communication status file for the Micrologix 1400. For the 1100 it's called ES, and for the 1400 it's ES1. Then there's the I/O module status file. Now none of this is available for the 1000. This is all the 1100 or the higher processor numbers, like the 1200, 1400, 1500, etc. The function files always exist in the processor in non-user memory. They are a fixed length and reside at a fixed address in the processor. If you were to open up function files, and we're not going to, because remember, we're doing I/O and channel configuration. But I also promised in the title a comparison between the 1000 and 1100. The STI, EII, HSC, high-speed counter, PTO, pulse train output, PWM, pulse width modulation, etc., and DAT files are always included when a program is downloaded or transferred from a memory module. The RTC, BHI, MMI, and TPI, these are other data types, are not included in a download or program transfer from a memory module. Now at this point, if you're a beginner, you should pretty much ignore everything I said in the last 4 or 5 minutes because you're not going to deal with any of this. But again, I promised a little comparison. Now let's look at the two things in front of us and compare them. Okay, so I burned up a bunch of time talking about the function files right here in the 1100. We're not going to deal with those at all in the Complete PLC Learn series. But because you could use either one of these controllers with the MicroStarter Lite, you're going to see function files and wonder what it is. Well, you've had a little introduction now. Before we do I/O config and channel config, let's compare program files and data files. Well, the 1000 has a fixed set of data files and does not support any data types other than what you see here. No floating point data type. So if we scroll down here, you'll see that you have status, binary, timer, counter, control, and integer, and that's it. If you go to data files and right click, you can't create any new data files. Okay, so there is no floating point or any other data types other than what you see right here. However, if I go to data files, well, first of all, you can see F8, file number 8, and F stands for floating point, not for file. These are all memory files, data files, where data is stored. If I go to data files, see, now I can click on new. You couldn't do that over here. You can't add new data files to the 1000, but the 1100 you can. And if you look at the type, you can add more memory files, each one of these different types. Now remember, binary, timer, counter, control, integer are available in the 1000, and that's all. We're in the 1100 now. So in addition to those, you have float, string, long, message, PID, programmable limit switch, routing information, extended routing information. These are data types. The bottom three have to do with communications as well as the message instruction. It's just a different way of doing a message instruction. The file number can go as high as 255. So let's punch in a 255 there. It's binary is selected. So let's say OK. Now look over here. We have, you know, your output file, input file status, and really you have no ability to change those unless you're adding I/O, but the status is fixed. So B3, T4, C5, R6, N7, and F8. Those are your default files. I just created a B255. The only difference between B3 and B255 is it's a separate data file. That's to help you with your organizational efforts. So over here, you really can't change the program files. See, there's no new, right? If you go over here, well, it starts though over here with, by the way, System 0 and System 1. Those, you can't touch those. I think they just put the text here to let you know that there is a 0 and a 1 in case you see ladder 2 and you go, well, I wonder what happened to ladder 1. Well, there is no ladder 1. There's a System 1, but there's also a System 0. You see that on both processors. But on the 1000 over here, you have ladder 2 through ladder 16. And ladder 16 has got a little bug on it because that's typically where you put debug stuff. And ladder 2 is normally your main program because ladder 2 is the only ladder file that executes automatically when you put the processor in the run mode. Ladder 3 through 16 take some extra coding effort on your part, usually with a JSR, jump to subroutine, to actually execute these other ladder files. My point is, not only are the data files fixed in the 1000, but so are the program files, which is basically ladder 2 through ladder 16. Over here, though, for the 1100, all you have is a ladder 2. But you can click on program, right-click on Program Files, New, and you can add program files all the way up to and including 255. See, now we've got ladder 2 and ladder 255. We could have a ladder 99. We could have a ladder 73. They don't have to be contiguous. That's the same thing with the data files down here. See, we went from 8 to 255. You don't have to have a 9 to have a 10 to have an 11. You can name them anything you want, any of those data types, but it has to be between 2 and 255. Okay, let's see what else can we wrestle out of this. Scroll down here. Force files, custom data monitors, graphical recipe monitors. There is one other thing that the 1100 has that the 1000 doesn't, and that's RCP configuration files. Those are for recipes. We're not going to talk about recipes at all in the Complete PLC Learn series. Once you've mastered what's in the 200 plus page manual, once you've mastered all that, well then by all means go out on your own and start working with the recipes, except you really won't find anything to work with in the 1000. You're going to need at least an 1100. Now if it was me, I might start with a 1000, but if I had the money to spend, I would probably go with a 1400 and buy not just the 1400, but I would also buy the standard version of Micrologix1100, that, or at least whatever the least expensive version is that will program the 1400. That will give you everything that you need to work with for the entire Micrologix1100 platform systems. Okay, I think that tidies up comparing the difference between these two processors, except, remember, this was channel configuration for the Basic 1000. This was I/O configuration for the Basic 1000. Now we're going to do I/O configuration for the 1100. Now the first thing you notice is that it shows the processor, Micrologix 1100 Series B, Bolton 1763, but it also shows 1, 2, 3, 4. That means that the memory, or the firmware, and the firmware of the Micrologix 1100 supports more I/O memory data structure. So typically with a 1000, you have a I/O memory structure that represents the fixed I/O that comes actually on the Micrologix brick. With the 1100 comes with fixed I/O on the brick, but it also has a parallel port on the right end of the processor that can plug into additional modules going to the right. And you can have modules 1, 2, 3, and 4. And by the way, the first one, whatever module you put in slot 1, that's in slot 1. You don't put one in slot 4 and then expect something magic to take place in 1, 2, and 3. So whatever module you're going to attach directly to the right of the processor, that goes in slot 1. Well, just for grins, let's expand our inputs and add an IQ16. So if I click on that, nothing happens. But if I double click, it pops in there. And let's go for an 8 output relay. Now let's be greedy. We'll go to an OW16. So now we just expanded our basic I/O capacity to, we've increased it to 16 more inputs and 16 more outputs. And then for grins, let's do an analog. So let's do an analog 2 in and 2 out. And we got one more slot that we could fill up with something. We'll just throw in thermocouple or RTD. We'll throw in thermocouple. Okay, we filled up our I/O structure, but you know, I just realized something I wanted to show you first. So I'm going to delete, right click, delete, right click, delete. I'm going to close this, and then I'll come back to this in a minute. I wanted to show you the input. We'll put that up here. We're going to lock it on top. That way it doesn't disappear on us. And it allows me to move it up a little higher here. And we'll scrunch it up. Well, we'll leave a little open there. So you see you have word, or actually 0, words 0 through 5, 16 bits each for input memory structure. This is just the bare bones Micrologix1100. Now let's do the same thing with the output. I'm going to open it, lock it on top, and we'll move it over here right below it. And want to keep it in your view, so they'll be overlapped a little bit, I guess. Okay, so you see you have 6 words and 4 words. So you have 6 words, 4 inputs, but they're all file 0, right? 0 word, or if you want to say slot 0, in 6 words in slot 0, 4 words in slot 0. They're really not called slots, but let's just pretend. Now, let's go do this I/O config again. And I can't lock that on top, so I'm going to have to move that over. And we'll add those modules in again. We had an IQ16, we had an OW16, we had an IF2, OF2, and then we did thermocouple. Okay? Did you see over here what happened as I was adding them? Let me do that one more time, because I meant to tell you to watch. Okay, we're back to 6 and 4. So I'm going to add in an IQ16. Now, where do you think the data image for that module would go over here in the 2 data files? You got one for input, one for output. Well, it's a no-brainer, right? So I'm going to double-click on the IQ16. Notice that that word added another word, but see, it's slot 1 now. So remember over here in our rack, if you want to call it, that's not really a rack, but in position 1, we've got an IQ16. See, position 1. So position 0 is the processor, position 1 is the first module. So we'll go back over here, and we'll add an OW16. And where do you expect that to pop up? Over to the right there. You got it. Position 2. You've got a word for that card. Then we wanted the analog. Now watch both the input and the output. There you go. Look at that. So now you've got, I don't know if we can stretch this out a little bit more or not. Yep, we can do that. So now you see you've got, for position 3, you added 6 more words. We won't go into why now, but I just wanted you to see what happens. And for the outputs from that analog card, we added 2 here. Now we got one more card we can throw in there. I think that was a thermocouple. Now you see, scroll down, look, we just added 6 more words for the input and none for the output. So that thermocouple input card adds more structure to the input data file, I1, did not add any to the output. Okay, so I'm going to close these to get them out of our face, and then I'm going to move this back over where you can see it. I want to say a few more things. Well, there's 2 more buttons. Notice, you probably didn't notice, but I think that when we added that one, we got advanced configuration. We're not going to go into any details on that because it's going to vary per module that you add. So we would have to go through all of them that have advanced configuration if we were going to even do one. So we're not going to do that. However, as we're adding these, or you're adding yours on your project, when this button becomes live, click on it to see what's there. Now, 2 buttons up here. One is Read I/O Config. If, and only if, you are connected to a processor that has I/O cards, you know, in positions 1, 2, 3, and 4, or just even position 1, it's all powered up, your driver's working. If you click on Read I/O Config, it's going to ask you to point through what driver you want to read I/O config. So basically you're pointing at the actual live hardware, the processor. When you click Read I/O Config, it sends a message to the processor that tells the processor to go look on its backplane and report back who's sitting there, who's plugged in. If you start with a live processor with the modules connected, you don't have to add these in. You can just click on Read I/O Config. Now, this was very common back in the SLC 500 days when that was the most popular product of the AB line. You would put all your modules in the slots and then you would do the configuration. That saved you a lot of work. You could just read I/O config. Well, if you want to call that discovery, that's cool. But if you're not hooked up to the processor, you can't use it. And if the processor doesn't have any modules added onto it, it's not going to read anything. Last but not least is the power supply. Now, the power supply is not going to yield any real information because the Micrologix1100 either has a built-in power supply or has an external power supply. Where this would come in handy on other projects is when you wanted to specify what power supply that you had. Now, you can do that. You can specify other right here, and you can put in the current capacity for whatever power supply you're using. So all this is going to do is yield, see it says informational only right up there at the top of it. It's going to yield information that will assist you in determining if you have enough power supply to power these particular modules. So we'll click OK because we really didn't do anything there. Now, there is no OK on this. As you change things, it's changing it in the configuration. So we'll close that. And there we have the I/O configuration. Now we'll click on the plus sign here so you can see there's channel status, but we'll leave that for now. Double click on channel configuration. The configuration choices that you see here are outside the scope of this presentation. If you are advanced enough to change these, do so with instruction or assistance from the documentation that you can download from the manufacturer of this controller or the user manual. So we're not going to change anything here. We're not going to discuss anything here. We're going to go to channel 0 tab. Now, when you look at channel 0 tab, this half of it looks familiar to you. However, you have a few more choices here, especially if you want to use Modbus, which there's a lot of products that'll work with Modbus with the 1100 and 1400 and some of the other processors. But we're going to leave it DF1 full duplex. Notice it comes 19.2. You see another one, 38.4. I would stay away from 38.4. You can try it to see if it works for you. And of course, parity and source ID. So there's nothing here to change other than the baud rate for your RS-232 port. Remember, there's two ports on this 1100. Channel 0 is RS-232 and channel 1 is Ethernet. If you're familiar with Ethernet, there's not much to explain here with the exception of boot P enable. Boot P and DHCP are very similar with the exception that boot P always assigns the same IP address to the MAC address that it was originally assigned to. If you don't know what the MAC address is, spend some time learning about Ethernet before you start changing anything here. The hardware address and the MAC address are really the same thing. Every Ethernet device on the face of the earth has a unique MAC address, model access carrier or hardware address. The actual Ethernet address is the hardware address. The IP address, however, in a sense is temporary. Notice this is all grayed out. Here you have boot P enable. Let's uncheck that. You could also check DHCP, Dynamic Host Control Protocol. And this is grayed out. So if either one of these are checked, this is grayed out. Typically, and let me explain something about boot P enable and DHCP enable. Those two, if either one's selected, we'll just go through that. Boot P enable, that's selected, then when your processor powers up, it sends a message out of the Ethernet port and it sends out a message that is broadcasting out there to any servers that are listening. and it sends a request for IP, and it gives its MAC address. With BootP Enable, BootP Enable is set up originally with a MAC address and an IP address. So if you use BootP Enable, when this processor powers up, it sends out a message. The server sees it and sends it its IP address. It's always going to be the same. And for control systems, you want the IP address to stay the same. However, DHCP, typically, it does the same thing. It sends out a message with a MAC address requesting an IP. The difference is it's going to lease you an unused IP for a certain length of time, normally 72 hours. It gives you an IP, and let's say you shut down for some reason, and 2 days later, 3 days later, 4 days later, well, more than 72 hours later, you power back up with DHCP set. It sends out a message, and the server is going to send you the next unused IP address. It won't be the same one. That could be, but it's very unlikely it'll be the same IP that you got last time. The problem with that is when you're doing messaging and any other type of control communications, each device on the network is expecting every other device on the network to stay at the same IP. Otherwise, it's going to send a message to an IP address that is not assigned to anyone. So if you're going to use any kind of a dynamic host strategy, you need to use BootP Enable. But in order for that to function, you have to have a BootP server. In other words, you have to have a computer on that Ethernet network that is capable of receiving a message, looking at the MAC ID, the hardware address, the Ethernet address, looking in a lookup list, and then sending the same IP to that particular device. So uncheck BootP. Okay, if you're going to use Ethernet, uncheck BootP, but you're going to have to put in an IP address and a subnet mask. The rest of it is really not necessary, but it has to have an IP address and a subnet mask. Now typically, by default, you're going to get something. So if I punch in 192.168.12.100, well, it didn't give me one. So you're going to put in whatever subnet mask you want. Now, I typically put in this subnet mask, meaning that my network has only 256 nodes on it. And of course, you don't use node 0 and you don't use node 255. Remember, 256 is 0 to 255. That's enough on Ethernet. You need to study that in a different venue than this particular presentation. I'll just leave that address in there because you're going to do something like this. Now, if you're communicating between your laptop or your work computer and this 1100 with a Ethernet cable, first of all, if it's going direct between your laptop Ethernet port and the PLC's Ethernet port, you need a crossover cable because you need your receive to go to the other end's transmit and vice versa. If you're going through a router or a switch, not a problem. Any Ethernet cable will function. Also, your laptop Ethernet port will have to be set up in the same subnet, which means for this setting right here, your laptop will have to be 192.168.12 and then anything besides 100. But if there's more than one device on that network, you have to know what those other IPs are. You can't do duplicate nodes. Okay, we've got far enough off the track here with this. I will close this, and let's see what else didn't we cover. I think that pretty much nails it for I/O configuration and channel configuration. Well, I think that pretty much concludes the PLC Professor presentation on I/O configuration and channel configuration with the included comparison between the 1000 and the 1100. You could also use a 1200, 1400, or 1500. I would say the 1100 and the 1400 are the two main players for the Micrologix family because they both have built-in Ethernet and they have online programming. Thank you for watching.